All right, well, hello again, everybody. We're going to go on with Chapter 5, Section 2, Type 1 and Type 2 errors, when we just talked all about hypotheses. So now, after analyzing your data, you have two options. As I said, we always do our statistical testing on the null hypothesis. So that's that hypothesis of no effect. And you have two options. After you collect your data, run your statistical test, you are left with either rejecting the null hypothesis. Now, again, remember the null hypothesis is the hypothesis of no effect, that the groups are the same. So if you reject the null hypothesis, you are saying, hey, that null hypothesis is not true. I reject it. And actually, there was a difference between the groups. Or you could fail to reject, or you might say accept, the null hypothesis. If you fail to reject the null hypothesis, that means you're going to keep the null hypothesis. And the null hypothesis is that there is no difference between your groups, and you're concluding that there was no difference found. So to keep in mind, we're always talking about the null hypothesis, and we have two options. We reject the null, or we fail to reject the null. Now, this is definitely a bunch of mental gymnastics. Think of this as like brain yoga in terms of thinking about what these words mean and what sometimes it's a lot of negatives, like two negatives in a row, which makes it a positive. Anyhow, you just have to try to think through these statements as we go through this. So when we do our inferential statistics, starting in Chapter 7, we're basically going to be making decisions about the null hypothesis. And those decisions that I said were either reject the null or fail to reject the null. Okay, take a look at this and don't worry too much. You can ignore all of these symbols at the bottom. What we're really looking at in this table is the two correct decisions and the type 1 or type 2 error. I'm going to explain this chart to you in a bunch of detail. I have a couple of other charts to help make it a little bit more clear, and by the time I'm done, hopefully this will make a little bit more sense. But here we have a bunch of these new terms, again, like speaking a second language, so stick with me on this. The first time you hear it, it may make no sense, but if you listen again and again and listen to some of these other examples, hopefully by the end of this lecture, you'll have a good understanding of what these terms are. So let's look at how the table is set up. We have population and decision. So population means if we are doing a study, let's say on that reading program we had talked about in the last lecture, summer reading program where we gave children who every time they read a book over the summer they get a prize. And we want to know if this reading program works. Well, in the population, there is an actual truth out there. If we tested every single second grader, which would be the population of second graders in the United States, we tested the entire population of second graders with this reading program, meaning I would go and give prizes to every single second grader if they read a book over the summer. I would actually know the answer of whether or not my reading program works. Either it works or it doesn't. If the null hypothesis is actually true in the population, what does that mean? If the null is true, it means there is no difference in the amount of books read by students in the reading program or students not in the reading program. And so there is no effect of my treatment program, of my new reading program. Or in the population, it's possible that the null is false, that we actually see kids start to read more books when they're in the reading program, in which case the null is false, that the independent variable does have an effect. Now remember, I'm saying this is happening in the population, and we really never test the population. Would I ever go out and try to start this reading program on every single second grader in the country? No, it would be, a study that would take me 50 years and, lots and lots of money. So even though there is a truth out there, there is an actual truth. If you went and tested everyone in the population, we don't know it. Instead, we test a sample, like a sample of 100 second graders, and we make a decision based on that based on that sample data about the null hypothesis. And our decision, as I said, we're always looking at the null, and we either reject the null hypothesis. If we reject the null, then we're saying, hey, that null is not true, meaning there is a difference between the groups. My reading program does improve reading. Or we accept the null, in which case, based on our data, we say, oh, there wasn't enough in those hundreds students who were in the reading program, it didn't change their amount of reading of the book, and so I'm going to accept the null. I'm going to say that my reading program doesn't work. So this group here, this is our decision based on sample data, and this is in the population, the actual truth. So if you set your data up in this way, you've got four possible outcomes. So if based on our sample data, we reject the null, meaning that the children who were in my reading program group, those 50 children in the reading program group, read many more books over the summer compared to those not in the reading program group. So we reject the null, we say, hey, that independent variable is effective, the reading program is effective. And if in the population the null hypothesis is false, that really this reading program does work. If we tested every single student, second grade student in the country, we'd find that it would work. Well, we're right here, we've made a correct decision. Yay, and we're very happy. If we, based on our sample data, we accept the null, perhaps then there's no difference in the amount of books read by the 50 children who participated in my reading program and the 50 children who didn't. In that case, we accept the null. We say, you know what, this reading program doesn't work. There's no effect of this reading program on number of books read over the summer. And if, in fact, the null hypothesis is true, meaning that we actually went out, if we could have tested every single second grade child in the population and found that actually this reading program does not impact students' reading over the summer, the null is true, and we've accepted the null in our study, then again we've made a correct decision and we're very happy. But you can see that there are two types of errors we could make, and statisticians have so creatively named them type 1 error and type 2 error. So what's a type 1 error? A type 1 error is when you, in your sample data in your study, reject the null. We say, oh my goodness, in this sample, the 50 children who were in the reading program read many, many, many more books over the summer than those who were not in the reading program. I'm going to conclude that this reading program works. And I'm going to start advertising it and selling it. I would think every school district in the country should be buying this program, and I'm going to make lots of money. And so I make a big deal about these results. But what if, actually, if I tested everyone in the population, the null hypothesis is actually true? Meaning that there really is no difference in the amount of books kids read over the summer, based on whether or not they're in the reading program. And that this data I got here we will call sampling error. Perhaps just by chance and by kind of an error, when I picked people to be in my reading program group, they just happened to all be very, very big readers, and they would have read that many books over the summer regardless of if they were in the reading program or not. But if we went to test everybody, we would find the null is true. So we've rejected the null. We've said, hey, this independent variable has an effect, when in fact in the population, the null hypothesis is actually true, that IV does not have an effect. We have made what we call a type 1 error. This is what we also call a false alarm. We're saying, hey, this independent variable works based on our study, when in fact it doesn't. It's a false alarm, type 1 error. The other type of error we could make would be if, based on our sample data, we accept the null. We say, hey, our research study shows that this reading program doesn't work, and children who are in the reading program or not in the reading program each read the same number of books over the summer, so nobody should buy this reading program, and I'm going to file it away in a filing cabinet and never look at it again. I've accepted the null. But what if in the population, if I tested every single person, every single second grader, I would really find that the null is false, that actually there is a difference, and that program does improve reading. Well, in that case, I've made a type 2 error. We call this kind of error a miss. I've missed it. I said, based on my sample data, this independent variable of reading program doesn't work, but in actuality it does. If I tested the whole population, I've missed that effect of the reading program, and I've made a type 2 error. So let's look at another example that sometimes can make it more clear. This is a jury example. Maybe some of you have been on a jury. If not, I'm sure you've seen a jury on TV or a movie. And so let's imagine we have we're a jury, and it's a trial for someone is accused of stealing a car. So actually, there is a real truth out there. This defendant actually either stole the car, he's guilty, or didn't steal the car, innocent. There is an actual truth out there. That's kind of like our population data saying there's an actual truth out there. But we don't know it. We didn't see it. We're the jurors. So we have to make a decision based on the evidence presented in court. We come up with a verdict based on the evidence presented in court. And again, that's similar to making a decision based on sample data. We've got a little bit of data we've got to make a decision on about what actually happened. So we've got a couple of choices here. We either find the person guilty or we find them innocent, and that's it. So if we find the person guilty, based on the evidence, we say there's enough evidence this person is guilty, they need to go to jail, and in fact, they really are guilty. They did steal the car. Well, you've made a correct decision, and this is great. You've sent a guilty person to jail to pay for his crime, or her crime, right? Could be either. However, we could also make the decision based on the data that the person is innocent. There's not enough data presented in trial. There's not enough evidence presented in trial to find the person guilty. We think they're innocent. This might have been a case of mistaken identity or something like that. And if in fact the person was innocent, well, again, we've made a correct decision and we're very, very happy. But we can make these same two types of errors. We could, based on the evidence presented in court, find the person guilty, send him to jail. But in actuality, the person was innocent. He did not steal the car. Well, we've made a type 1 error. This is a false alarm, right? And you've heard of this happening. There's news stories where somebody's been in jail and then with DNA evidence or some kind of evidence, they realized, oops, we have the wrong person, and they let them out. This is a type 1 error or false alarm. We find the person guilty based on our data or evidence in court when in fact the person was guilty. And this is just like a type 1 error in our experiment or in our statistical findings where we say, yep, our independent variable has an effect when in fact it doesn't. The other type of error we can make, type 2 error here, this is if based on the evidence presented in court, we, as the jury, find the person innocent and let him go, when in fact he was guilty. He did steal the car. This is a type 2 error or a miss. We've missed it. And this is like accepting the null hypothesis. In our statistical study, we accept the null. We say our independent variable has no effect, when in fact it does. Again, it would be a type 2 error. We missed it. So a type 1 error or a false alarm, that's when you reject the null hypothesis. You say, oh, that null hypothesis is not true. And remember, the null hypothesis is the hypothesis of no effect. So we're rejecting the hypothesis of no effect. But in fact, it is true. There is no effect if we tested the whole population. This is when we actually, based on our sample data, we say there's a difference between our groups when there isn't in the population. This is like deciding someone is guilty when in fact they're innocent. Now the big thing to remember here is, do we ever really know what's happening in the population? We don't, because we never test the population. So we never really know if we're making a correct decision or we're making an error. So this type 1 error is a false alarm, rejecting the null hypothesis when it's true. We're gonna skip this. We'll talk about this as we move on into some other chapters. Type 2 error is a miss. This is when you accept the null when in fact it's false. So you accept the null hypothesis, you say, yes, based on my sample data, the null hypothesis, I'm going to fail to reject the null hypothesis. I'm going to keep the null hypothesis, which means that my independent variable did not work. When in fact, if we tested the whole population, we would find that the independent variable is effective. This is like saying there's no difference between your groups when there is, or deciding someone's innocent when in fact they're guilty. There is an inverse relationship between type 1 and type 2 errors, meaning we actually set a level or we set a criteria. We usually use 0.05 as a 5%. We set a 5% chance on any study that we're making a type 1 error. And we'll talk more about this, but this is something that we as a researcher choose, and typically we set it at 0.05. We say the alpha level is 0.05, which means there's a 5% chance for making a type 1 error. The lower your chance of making a type 1 error, the higher your chance of making a type 2 error. The lower your chance of making a type 2 error, the higher your chance of making a type 1 error. That is this inverse relationship. All right, and how you would decide, do you want more type 1 or more type 2 errors? How do you make that decision, basically, is based on each situation in each study. And so if we look back to this juror example, which is the worst error to make, a type 1 error or a type 2 error? A false alarm where we sent an innocent person to prison, or a type 2 error where we let a guilty person go free? Which is the worst decision to make in this case? You may have your own opinions. Our justice system is set up that we do not want type 1 errors. We do not want to send innocent people to jail. That goes kind of against our legal system of innocent until proven guilty. And we give jurors a very high criteria level for making a type 1 error, for finding someone guilty. If you probably heard this term before, beyond a reasonable doubt. That's a very high level. The evidence has to go above in order to find somebody guilty. And by making that so tough, we are assuring ourselves we're not going to get too many type 1 errors. We'll always get some, but not too many. But because we make it so hard to find somebody guilty in a court of law, what happens? We make a lot more type 2 errors. There's a lot more misses, because there may just not be enough evidence. Even if the person is guilty, there's just not enough evidence that they can present in court to reach beyond that criteria of beyond a reasonable doubt. And so the jury must find the person innocent even if they're guilty. Type 2 error. A miss. And we've heard these cases before, and sometimes if it's a case in the news and you hear about it and you're sure this person is guilty, and yet they go free. And we're all thinking, why? Well, perhaps because that evidence did not reach that criteria of beyond a reasonable doubt, and the jury has no choice but to find that person innocent. So those are the two types of errors in our legal system, and our legal system is set up that we would rather make more type 2 errors. We'd rather have some more misses, let some more guilty people go free, as opposed to more type 1 errors. We don't want to send innocent people to jail. But what about this situation if you're a doctor? Okay, let's pretend we're all surgeons now. And we have a patient, and the patient either needs an operation or doesn't need an operation. This is like population data. Oops, sorry, it's a fact. The patient either needs the operation or doesn't, but you won't know for sure until you do the surgery. The doctor has to make a decision based on tests, blood tests, scans, ultrasounds, things like that. Based on the testing, they make a decision, either they're going to do an operation or not. So this is, again, kind of like our sample data. We've got to make a decision based on some little bit of data. And based on that data, you might decide, okay, we need to operate on this patient, and in fact, the patient did need an operation. When you get in there and do the operation, you go, oh, yep, here's the problem. I'm going to fix it. Great, we've made a correct decision. Person lives a long, healthy life because you did a great job on the operation. Good job. Or, based on the tests and ultrasounds and things like that, the decision is made not to operate. And in fact, the patient did not need an operation. Well, again, we've made a correct decision. Great, the person lives a long, healthy life. But which error here would be worse, a type 1 error or a type 2 error? A type 1 error is when you decide, based on the blood tests and the ultrasounds and things like that, you need to do the operation. And once you get in there, oops, the patient is opened up and we're looking inside and we go, uh-oh, they didn't need an operation, oops. So you back up. That would be a type 1 error or a false alarm. How do you think the patient would feel? How do you think the doctor would feel? Or perhaps we decide to not to operate. Look at the blood tests and the ultrasounds and say, oh, this patient doesn't need an operation, but in fact they did need it. We've made a type 2 error, we've missed it, and then the person a week later gets very sick or dies because they needed the operation and you made the decision not to operate. You missed it. Well, now which error is worse? Now this type 2 error, miss, seems worse. So it depends on the study, it depends on what you're looking at, if a type 1 error or a type 2 error is a worse error to make. So what did I just say? A type 1 error, we're just going to skip right down to here, a type 1 error, rejecting the null hypothesis, H sub 0 is the null hypothesis, when in fact it's true. And a type 2 error, fail to reject the null when in fact it's false. And remember, you never know if you're making a correct decision or an error because we never test the population. So we never really know what's going on in the population. So how do we ever feel confident in our results if we don't know? Well, it has to do with replication, doing studies over and over again. After one study is done, let's say on my new second graders reading program, and I find that it worked in my sample, well, I can feel good about it, and I'll publish it and say, hey, this is a significant result, and perhaps people should start thinking about using this reading program. But what I really want is more research studies done to see if other researchers who use different samples from different places in the country, if they also find this reading program to be effective, or what we say, replicate the results. And if, there's another 20 studies done, and all 20 studies find that children who participate in this reading program read more books, well, then we start to feel like, ooh, this is a correct result. We're all finding the same thing. We've got a correct result. But if I find that this reading program works and I publish a study, though the special Spilkin reading program is very effective and will help second graders read more books. And then 20 other studies are done using my Spilkin reading program, and nobody finds that it works. Then we might think, oops, my results might be a type 1 error. My results might be a false alarm. Okay. And that's where we are again here. It's repeating what I just said. A type 1 error, we call it, your book talks about it as sins of commission, where you're rejecting the null when it's true, you're saying something happened when it didn't. You're saying your independent variable is effective when in fact it isn't. Type 2 errors, sins of omission, failing to reject the null when it's false, saying that nothing happened when it did, or saying the independent variable has no effect when in fact it does. I know that's a lot of words, but hopefully you will replay this or read the book and kind of go over it again and again. But this type 1 and type 2 error we're going to be coming back to again and again throughout this semester. All right, everybody, good luck this week on Chapter 5. Bye.